differentiation. Correct. So normally the length, for example, if I am starting from this to this point to this point, point A to point B, 5 centimeter. Correct. So I'll take x is equal to 5 or AB is equal to 5. But if I take of an electron radius, radius of an electron, so that is not centimeter, correct? It is a very, very small size. So instead of x, I'll put something called dx. That is differentiating with respect to x. So for very, very small length, we say dx. Then comes something called integration. So integration is nothing but it is the opposite or reverse of differentiation. So we will try to prove how it is, but before that we should know some simple formula for differentiation. D by dx, differentiating with respect to x of x power n is equal to n power nx power n minus 1. So if it is differentiation of x power 1, so instead of n it is 1. So 1 into x power 1 minus 1. So 1 into x power 0, it is 1. Now differentiation of x square, 2x power 2 minus 1. So I'm just substituting only the simple formula, that's all. That is 2x. 2x power 1, that is equal to 2x. Similarly, for integration, we got a basic formula. Integral of x power n dot dx is equal to x power n plus 1 by n plus 1. So this I'll write down here. Integration, this symbol is integration with respect to dx. With respect to integrating with respect to x. Okay, if I just put a line, no meaning. It has got what? Actually, no meaning. This is no meaning at all, no meaning. But with this, yes, the meaning is there. So a basic formula for this is what? Integral of x power n dot dx is equal to x power n plus 1 by n plus 1. This is our basic formula. So if I'm giving integral of x power 1, n is equal to 1, I'll get x power 1 plus 1 by 1 plus 1. That is x square by 2. And please remember, I said what? Integration is the opposite reverse of differentiation, which means if I just take this value and differentiate, if I just differentiate d by dx of x square by 2. So two things are there. I am differentiating x square and by 2. But I'm differentiating with respect to x. I'll write down in words here, so it will be easy for you to understand. I am differentiating with respect to x. So which means 2 is not a part of x. 2 is a constant. Correct? 2 is different, x is different, or y is different. Correct? It's not a part of x. So which means here, what I can do is I can take this 2 out. 1 by 2 into d by dx of x square. And just now, I told you what d by dx of x square we already done here. Where? Here. It is 2x. So instead of writing the entire thing, I'm putting it as what? Here, 2x. D by dx of x square, I'll substitute as what? I'll substitute as, I'll just circle it down. Correct? I'll put it as what? 2x respectively. So which means 1 by 2 into 2x. Correct. So I can cancel what? This 2 and this 2. So I'll get the answer as x itself. So this x is nothing but what? This is what? This same thing. So when I integrated this x, I got what? When I integrated this x, I got x square by 2. And when I differentiated this thing, I got what? The question itself. So that's the reason they're telling integration is the reverse of differentiation.